Let's get started. So today, let's talk about Tesla Bot and the explosion of these humanoid startups all over the place. In the last month, in the last 2 months, we have seen so many demos being dropped, and the speed of innovation by these humanoid startups is it's mind-boggling. So I'm going to go through a quick list here just to keep everybody up to speed. We know Tesla Bot is got their Gen 2 Optimus dropped in December. It's very well designed. It looks like that it's close to, design lock if you look at just the way it appears. They then were able to show that it can do autonomous block sorting, and they showed that they were able to increase the walking speed by 30%. So we're waiting for even more improvements from them. In the meantime, they've been hiring bot job openings has just been in the hundreds at this point that we've been seeing. Figure Robotics did a massive raise of $675 million. They were able to show the bot is able to do manipulating a Keurig coffee machine autonomously. Then they dropped another demo where the Figure robot was able to do autonomous pick and place. We had Sanctuary dropped a demo recently where they were able to now show that they can do block sorting at human speed, both arms moving at the same time at human speed. Then we had Unitree drop a demo that they were able to show that their bot can do faster than human walking speed, and he can even jump up and down as well. And then I think a big demo that wasn't as impressive when you look at it, but in terms of a milestone hit, Agility dropped a demo where their bot can now do 7.5 hours of work straight. So that is a big deal that they were able to do that. And then 1X Technologies, they dropped a demo of their Eve robots. These are the ones with the wheels. They're about to come up with their own humanoid bot. Was that one called Eve and Neo will be doing, but Neo will be a full humanoid with hands, fingers, as well as feet. But Eve, they show 30 of them, all doing autonomous work in a couple rooms. Actually, maybe not 30. They know that they had 30, but in that room, there was definitely a couple dozen. So, and then Fourier, a Chinese-based company from Singapore, and then also they have a Chinese division as well. They showed that their company was visited by President Xi. So this is, fast and furious. All of these companies are coming out there. So what I'd like to explore today is ask the question, right? What are the ways that we should measure these humanoid bots, startups' progress? How do you guys think, if you do, that Tesla is in the lead, in what ways? And then with Jeff here as well, his expertise in manufacturing, I'd love to ask him the question of, what would it take for manufacturing bots at scale? What is Tesla's advantage? And how does these other companies, who at this point we don't know any of them, who are actually have manufacturing as a skill set within their own, or expertise within their own their own company, they would have to partner. And so how does that look when you or a company have to outsource it to another partner? So lots to talk about. So let's welcome Scott Walter. Scott is a two-time robotics company founder. So Scott, why don't you start us off with, what are the ways that you would evaluate whether or not the company's Tesla is in the lead or not? And then we'll go through the table that we created with Cern Basher that goes through each of the different categories as well. But why don't you kick us off?
Yeah, hi Herbert, and hello everyone. So yeah, there's certainly a lot of ground that everyone has to cover, from designing the bot. I guess maybe just roll it all the way back to Elon has always said, prototypes are easy, but production is hard. And when I saw the Optimus bot, I sort of flipped that script around and said, no. In this case, the prototype is going to be hard, but the production will be easy, or at least relatively easy compared to most production. And the prototypes are going to be hard because the big thing that you have to solve is the brain, the AI. Once you've been able to solve that, and if you have the capability of doing that, while the mechanics will be a little bit challenging, they're not going to be overall that challenging compared to solving the brain problem. We have had mechanical systems for decades that are able to do rather elaborate kind of manufacturing tasks. And what has usually made it very complicated is that, designing these systems is difficult, and also implementing them and making changes, or the flexibility that you would like to have, is what's always made hard automation very difficult to use somewhere else, because it's not a generalist. It's very specific and very good at that task. In order to become specific or general, you need to have a bot that can train itself or change tasks very easily with very simple instruction on what it is you want to do. So that is something that Tesla has clearly been working on, has years and years of experience, and they already know how to deploy robots with them. There are millions of them out in the roads right now running around. So we know they already have that expertise. The other thing that always helps, and I think that this is something that was brought up by Phil, who I think is in the audience, is this idea of eating your own dog food. One of the advantages that Tesla has is they understand the need and the requirement for the bot. That was really the whole reason for them coming up with the Tesla bot, not because it necessarily said, hey, this would be a great product that people would like. It's like, this is something we need internally for our own manufacturing needs. So that helps them understand the design, what needs to go into it, and allows them to iterate, let's say, a lot faster. So they clearly have a lot of advantages over just about everyone else because of where they're coming from, their experience, the capital they have, the fact that they can move very quickly, and almost the ethos that's inside. Again, raising funds is not going to be a problem for Tesla. They have more than enough right now to be able to spend on this project.
Okay. And so on this list that we've created, right, we've got the one way that we measure the success of these Tesla, these bots, humanoid bots, right, is, and we're just looking at the ones with a commercial focus. I think that's we certainly are looking at all the bots, but if they have just research, we haven't really dove into them so much. And we want to make sure that they're, in order for them to be humanoid, they need to be walking, and then we want to see if they've got plans to be walking or are walking. They've got hands, and have they demoed that they can actually do some sort of useful work? Have they integrated LLM and voice integration? And have they demoed autonomous work? And have they actually done or announced a pilot with some actual customer site workforce? And then, of course, the final one would be who are actually deploying bots. You could say that Digit and Fourier are actually selling their bots today. Fourier said that they're selling it to research facilities at this point, but they're for sale. You can actually buy one, get one in your hands, and do it. And I believe Digit is also selling it as well.
And also Unitree. Unitree also.
Oh, okay.
And we know that because we've seen it at Carnegie Mellon, and we've also seen it at University of California, San Diego. And they mentioned on their website that they were for sale to research organizations. So that's at least 3.
Yeah. Okay. So we can explore each one of them, but I think the big advantage that everybody's saying, like, so we're watching all these demos of these humanoid bots, and we're saying that's great. They look like they can do it. It's a demo, so we don't really know for sure. But one of the big advantages that Tesla has is, of course, the AI. But many of these other bot companies are partnering. So Figure partner with OpenAI, and others have a partnership with NVIDIA and OpenAI as well. So then people come back to manufacturing at scale. So let's throw that to you, Jeff. Can you answer the questions I pitched you at the beginning?
Yeah, thanks, Herbert. And I think it's the right question. And I love how Scott kind of talked through that huge advantage that Tesla has, which is actually understanding the application. And I think it's a good corollary to Tesla's FSD hardware and software effort that they're doing, where they actually design their own silicon and really understand the requirements of the responsiveness of the vehicle and how how consumers use the product. They understand it better than anybody because they sell directly to them, and they have all that data. They have everything instrumented and measured on their vehicles, and they understand the consumer and how consumers drive. And I think that corollary is going to help them, given the fact that they have all these gigafactories. They do about 80% of the content of the vehicle in their own factory, vertically integrated. So they're unlike really any of the other automakers that are at scale already today, or certainly the legacy automakers where they where they outsource most of production. Tesla brings that in house. So from a scalability and a manufacturing perspective, number one, I think Tesla will match the robot to the task better than anyone else will do. And I think that's an important thing, because sometimes, companies will say, well, I need this to be automated, or I need that. And Scott, who has a history of, doing, factory automation, would understand, like, there's some things that just should not be automated, or there's some things that should be automated in a very specific way, or you're not going to get the ROI you want, customer, on what you're doing, because you change your product too often, to get the kind of ROI. So there's all these implications of, like, what should be automated, what shouldn't be. But when it comes back to scale, all that plays into it as well, which is, like, once you really truly understand the customer requirement set and what should version 1 of this bot ultimately do, that will dictate a lot of the specifications and capability that are going to be needed for that version of the bot. And I fundamentally believe, just like Tesla does with their vehicles, that they're going to have rolling and multiple versions of their bots over, the first decade of launch. There's not going to be, a rollout and launch of the Tesla bot, and that's going to be the bot for the next 10 years. That bot is going to change, improve, and add functionality and capability over a period of time. But for that first year or two, it's probably going to be doing some very specific and important things that Tesla will determine in their factories. So I think all of that plays together, and it'll actually help them get to market faster versus working with discrete partners like a BMW or whatever, saying, well, I need the bot to do this. And for you to get money from me, I need you to, for it to do X, Y, Z. Tesla owns that whole loop. So in terms of scale, I mean, there's a number of things to think about. First thing, what Tesla is going to do is they're going to understand what the bottlenecks are, both for the near term and the long term, and they're going to own them. They will not outsource bottlenecks. They will use suppliers in those situations, but that doesn't necessarily mean they're outsourcing it. They're going to own, anything that could be critical to design, critical to functionality, and critical to supply. They're going to own it, and that Tesla has a history of doing that, and that's going to give them a distinct advantage over others. So Tesla has, if you look at the job postings, Alexander does a really good job of looking at this. Tesla has been hiring industrialization people pretty much for the last 6 to 8 months on the bot, very early. In the development timeline, they've been hiring people that are thinking about how to build and scale this thing. And then recently, over the last couple of months, they've added supplier industrialization people to it, people that can do work on the actuator supply chain and so forth, and how that's going to come together. So I think Tesla's going to have a very distinct advantage. One is they already produce small microelectronic devices today. They build Starlink terminals, and then they build all the way up, devices, the product that are as big as automobiles. So they have a lot of experience dealing with metallurgy, forming large pieces of metal, and then forming smaller pieces of metal, and dealing with that, and then all the testing and calibration that's involved with microelectronics, all the mechanical testing that's involved, the reliability testing that's involved. They have all this experience, and it radically changes. When you're somebody who builds and ships vehicles only, or you're someone that builds and ships maybe smaller consumer electronic devices only. Whereas Tesla, it really does that whole spectrum of that, and they'll call on whomever they need, whether it's somebody from the aerospace, SpaceX side, or somebody from the Starlink side, or somebody from, the Tesla side, where the home base of this is. So one, they're uniquely positioned in terms of having the assets in their company already that have put this range of product into scale already. Two, they run a highly platformed approach. So they'll look to reuse, whether they may use the same type of aluminum from a particular part in a vehicle. When I'm saying the same raw material, not the exact same form part, but they'll look to use common materials. If you look at the inference board or the computer that would go on the bot, it's the inference board that that's in the vehicle today. So they're going to do a highly leveraged model so that they're not going to run into the problems of bringing up, taping out, either doing their own silicon, which they're already doing, but they're not going to have to bring up their own silicon to bring up their own bot, or they're not going to have to be beholden to somebody who's selling the silicon, who's on allocation, just like NVIDIA's put everybody on allocation right now. They're going to own their own supply chain. They're going to be beholden to themselves. So they want to put them in vehicles or they want to put them in bots, and they'll control that demand signal to Samsung, who's ultimately fabbing those chips, and then to their PCBA supplier, who's building out the full computer for them. So they have that advantage.
Okay, no, thank you. Sorry, I didn't want to interrupt you, Jeff, but I want to drill in a little bit more, Jeff, right? So I want to understand truly how big or important this advantage is, right? I'm going to push back a little bit. So clearly, Tesla has the ability to manufacture at scale. They are a company that can do that on EVs. They can definitely do that with bots and all the advantages you gave. But there are companies like BYD that came out of nowhere, created batteries, and now we're able to create EVs and cars, and they learned the skill, created manufacturing, and are now able to build factories like that too. And then I'll pair that with what Scott said at the very beginning. Scott thinks that a robot is a lot easier to build than you think, because it's actually, compared to an electric vehicle, it's 1/30 the weight, right? The less parts. And it could be a lot more standardized. A lot of the parts could be standardized and it's less. So could companies who are not Tesla be able to partner and outsource this and and catch up? And no one's going to ever catch up to how fast Tesla can build factories and how fast they can automate this. I'm just saying that is this such a big, like everybody thinks it's like the biggest advantage?
It is.
Or is it really that big of an advantage versus the AI? What is the biggest competitive differentiator for Tesla versus the others?
Well, there's two things. One is volume and one is economics. So you have to, when you think about scale, you have to think of it on a volume scale, and you have to think of it on an unit economics scale. So we don't know these demos from Figure and some of these other companies. How much do those bots cost at launch and production? We don't know the answer to that question. We don't know if they know how to form a supply chain, or if they know, if they understand the designs that they've done and what they would look like at scale from a yield perspective. Tesla's already thinking about that. They come from a business that does that. Your comment on BYD, I was in a BYD car in 2005 being driven around the campus in Shenzhen. So they've actually been in vehicles for quite a long time. And they didn't really so much come out of nowhere. They've been actually at it as long as Tesla's been at it on the vehicle side. But yeah, so to answer your question, people always look at supply chain and say, well, everybody will eventually figure out, just like smartphones. Like anybody will just go get work with a partner and get a phone made. Then the next thing that trips you up are the economics, which is, okay, as soon as you go to a partner, now you're sharing margin with them. And then the economics start breaking down. So what are you sharing economics on? So if you go to an assembly partner, you're sharing the economics on the entire general assembly. If you're going to a silicon partner like an NVIDIA for inference, you're going to be sharing economics with them. Right now, you got to pay NVIDIA anywhere from 60 to 80% to get a ticket to ride with their silicon. So when all this adds up, you actually stack up all the cost structure of the product. Do you have something at launch? And then do you have something over the life cycle of the product that will actually work from a lease or from a purchase perspective? Will those economics even work? We know the answer today in EV. Right now, today in EV, there's arguably only one company that's making EVs at scale that actually has good gross profits per vehicle, and that's Tesla. BYD's has been negative and maybe slightly positive of late. But you shouldn't, notice Tesla didn't have to get to a 3 million unit run rate to get to gross profit break even on the vehicle side, because they because of the work they did on engineering the vehicle and how they engineered their factories, they didn't have to get to that run rate to be massively profitable. They didn't have to get to that unit run rate that BYD has had to get to just to break even. And by the way, we don't even know honestly where BYD is on EVs. We don't know, exactly, because we don't know how well they split up their their EV, their pure EV versus their PEV side. So to answer your question, Herbert, everybody will be able to produce a prototype. Everybody will be able to make a demo. The question is have they done the underlying homework to scale, the silicon piece of it, all the components, all the electrical side, all the mechanical side, the actuator side? I think is going to be a huge bottleneck for people to figure out the complex actuators, the ones that are really driving the detailed motion in the fingers. And it'll be from a yield perspective. We'll be able to yield it. Have they done all that homework? And then once you think you've done all that homework leads into then the economics homework, which is, have you designed a supply chain in terms of what you do versus what you buy? And have you done it in a way where you've kept things proprietary that you need to keep proprietary, and you've kept things inside that you don't need to pay a margin on, and to do all those economics work both at launch and at scale? And because this is what could happen with some of these startups. They could okay, we get something to launch and they build a couple thousand bots, and they realize hey, I got to get to an annualized run rate of 1 million units before my business breaks even. My business breaks even. So it's, when you think of supply chain and you think of scale, it's not only volume, it's volume and economics.
Okay, thank you for that.
And I think of all the players that have, I can't look at any of those players and really, I can't, I have to go through and look at it again. I don't know if who has the experience at scale to do this stuff.
Yeah, Jeff, can I ask you kind of a question on manufacturing? DFM, or design for manufacturing, is something that everyone is taught in engineering school and what you're supposed to do. And it's one thing to have been preached it, it's another thing to actually practice it. So you can sit there with the best intention and designing everything to be manufacturable, and then you go to actually build it the first time and you realize everything you didn't know about design for manufacture, and you have to go back and do it a couple of times. So I'm assuming that is one huge advantage that Tesla already has, is that they've made those design mistakes many, many times. So going right back to using the Lotus for the Roadster and everything else, they learned all the problems, and of course the teething problems with the Model 3 that they're getting better and better. So I would think at this point they're not going to make the rookie mistakes. It's still possible, there's something in there that we don't understand, but when I'm looking at it, I don't see any elements in there that are challenging, like the Cybertruck launch or anything like that. I would think everything's going to be straightforward, but even then, it helps to have a good design perspective, because it's all going to come down to the margins in the end. And you can design the best actuators in the world, but if they cost you 3 times more to build than you thought, then you've lost your margins right there. And we all know the actuators is probably the most important. It's going to be the highest cost component in these bots. There's no doubt about it. Everything else is probably dirt cheap.
Yeah, and so the my team and we teach DFX, and that's one of the things that we help companies with, is bringing that capability up, because that ultimately teaches you how to design a part that can be produced at scale at its lowest price point, that gives you all the functionality you need. And if you're just kind of a green company just coming out of nowhere, that's difficult to do. There's tools out there, there's aids that can help you. But the whole DFM side of it, the whole DFX side of it is fundamentally how do you design the lowest cost part? First off, do you need the part or not? Do you need the process or not? And then if you need the part or process, how do you do it at the kind of the lowest cost to deliver the complete functionality? And yeah, you're right. That's where a lot of companies trip up on.
I think the argument, though, Jeff, is that unlike an electric vehicle, the profit is so high. Like, you can charge $90,000, $100,000 per year versus the cost, which, let's say it's $40,000 and Tesla's able to make it at $20,000. it's still profitable versus margins for an EV. It's so, it's like razor thin, and it's hard to get it past that point. And then you're going to be backed by the government. There's going to be a tremendous amount of funding for this to try to make sure that certain bot companies succeed. Well, so let me just step back and ask the question for both of you. Then, what is the number one, I guess, the barrier to success? Is it manufacturing, or is it the AI, or is it somebody else?
Yeah, they're two different. I mean, they're two radically different areas. I could see a lot of those companies on the list, Herbert, tripping up on the manufacturing side. On the AI side, I go back to Scott's point around they own the end solution of like, what does this shipping into? So they can gear the AI and gear all the test cases towards solving for that. It's just harder to do. Like NVIDIA today has to work with 80 different, they said they have 80 different partners on the autonomous driving side. How do you deal with like, which are the most important requirements to work on? What should I solve first? What should I solve last? Like, I mean, I know that they have an approach and a way to deal with it. I'm not saying they're just a bunch of, like morons running around with their heads cut off. But if you look at the Tesla side of it, like the inference team on the hardware, the silicon side and software side for the silicon, which would be the equivalent for CUDA at NVIDIA, that's all inside of Tesla. So they know, they've got the large team talking to them right there, like, look, this is what we need in terms of response time for airbag. This is what we need for this, we need for that. And there's just one team that's setting the requirements for the project, and it makes it a lot easier. So I think in the partner model, the problem you're going to run into, it's not impossible. And the partner model works. There's evidence of it working, like in mobile phones. Like Qualcomm is the modem, and MediaTek. They're the two major modems that are used in mobile phones today. And that partner model works. It takes many years to start that up and get it to working, but it works. So I'm not saying it's impossible. It's just there's a time lag to it, and then there's an economics lag to it. If you could own the whole thing from top to bottom, you can take out a lot of the margin you pay to people. That margin that gets paid to Qualcomm today on every 5G phone that ships does nothing for the consumer. Something is robbed or removed from that device, that phone you're using right now, that has no benefit to you at all. But Qualcomm has to get their, whatever the percent, 3 or 6% that they get for their 5G, that just has to go to them. And there's nothing you get as the consumer as a result of that. You get a great modem, you get something that's going to make and receive calls very reliably, but from a feature functionality perspective, you could be getting more in that product. So the partner model, you tend to pay for things that the consumer can't ultimately benefit from.
Jeff, would Tesla need to create a net new facility, a net new building to build these humanoid bots, or can they just take the existing building and then carve out an area there?
Yeah, the answer is they should be able to use their existing buildings. They're going to be different lines. The lines are going to look very different. And I'm assuming they may have versions of lines for their cars, they'll have versions of lines for the bots that'll start off at some manual automation ratio, manual versus auto, and that will improve over time. And then there may be a third thing will kick in, which will be manual versus auto versus humanoid. Like you have humanoids building humanoids. I'm sure there'll be some percentage of that at some point too. But yeah, it can go in an existing building. And I'm assuming it would be a highly kind of modular approach where there would be lines feeding lines. Like there would be an actuator line that's feeding the main general assembly line, and so the actuator area would be a separate area doing that. You wouldn't do an actuator in line with the full bot being assembled. You would have an actuator area that does nothing but, just like we have a motor inverter area in the factory. If you go and tour a Tesla factory, you'll see the motor inverter area. It's not in line with the main general assembly. It's a separate area. So you'd have But yeah, it could be a normal looking, factory building.
So that's a huge advantage. Scott, do you agree? Do you think that manufacturing at scale is going to be the biggest, criteria, the biggest wall that the others would have to cross over, or is it the AI or something else?
Yeah, it will be. I think, for me, again, it goes back to the prototype is going to be difficult. The production will be easy. And that comes down to having the AI. So if Tesla is able to get an AI solution well in advance of anyone else, they will be able to scale really quickly. And then it's, they get the lion's share, and they keep that lion's share because they'll be able to manufacture pretty quickly. I think I have a couple of questions for Jeff. Is that, I don't think the line for building a Tesla bot is going to be that big compared to what we're used to seeing in automotive. And so you certainly could fit it in any building. The question is whether any of those buildings have excess space that they would be willing to give up. Like Fremont right now is stuffed to the gills. So I don't think you want to put it there. And there's a reason why the mega packs aren't being built in Fremont, right? It's just like, put it somewhere else. We just don't have space. And of course, the mega packs, they didn't build anything special for that. They just took over existing property. So I think it's the same thing with the bot lines, is that while they could put it in an existing buildings, just, if it's somehow convenient, just because it's close to where the engineering is or something else, I don't think they need to, and they could easily rent out a facility and don't really have to build anything up very complicated. And
well, it's my understanding that if you look at the postings, Scott, sorry, the postings are for Sparks, Nevada, for like all the industrialization jobs.
Okay.
Around Sparks. It looks like they're going to do the initial, whether it's an NPI line, and for people like NPI's new product introduction, maybe it's not a full production line, but it's everything that's in a production line, but it's at lower volume. That's called an NPI line. They may do that at Sparks, and they may have their production operation at Sparks. I mean, they're doing this big addition in Nevada. So I'm assuming that's where initial bot production is going to come out of.
Yeah, I was guessing it would go there because, well, you already get the battery line there, and you're going to need some batteries. Not a whole lot, obviously, but at least you got that. And I think they have some of the other equipment there that could be useful for, like, the battery cavity that's going to go in the torso and other things. They can manufacture some of that at Sparks. And then it's just going to be a question of where that actuator line is going to be and where that's also set up in Sparks. My only concern with Sparks is whether they're just going to be able to attract the talent to go there, or whether it's just kind of, you're not really moving there. It's just going to be a 6-month stint or something like that. And most people might tolerate it. And then, maybe that's the whole idea of having the bots there, is then you don't have to worry about the fact that no one wants to live out there. Because that seems to have been what's really held that back. But then at the same time, Fremont is just crowded, it's expensive. You could also do it in Giga, Texas. The problem there is I think you're starting to run out of parking space already. It's kind of crowded. Maybe you want to find somewhere else to set this thing up, because I don't see that there's any specific location that it has to be, except that it might be not in an area that you would want people to live in and move to, and maybe be reasonably easy to get to for the engineering team. And so if that means somewhere near Palo Alto, then Sparks kind of makes sense for that.
Yeah, I think that's what they're doing. I think I think everything you've seen today has probably been built in a lab in Palo Alto, and then what you'll see, as they get into the hundreds and thousands, when they get this NPI line set up. I mean, I saw one of the roles. I remember one of the roles that was basically kind of like the system integration manager for designing, the first production line. And that'll be in Sparks. I'm pretty confident. And yeah, and the engineers, they've got experience going back. They did it for battery production. They did it for they've been doing it for semi. They will be doing it for semi. So yeah, they'll just shuttle back and forth.
Yeah, and it's not that bad. So long as you don't have 5 feet of snow, you can shuttle back and forth. And so What is it? Is like a 3 or 4 hour drive or something like that, I think. And, during ski season, it can be nice living out there anyway.
Yeah. And there's flights back and forth between Reno and San Jose, or Reno and in San Fran. But yeah, I think that's where that's where they'll do it. And again, I go back to this, Herbert, suppliers, volume manufacturing is not only can you get enough and can you pump out enough product, but have you solved the economics of doing that? And have you done all the work in advance, the DFX work that Scott talks about, and all the unit economics work? Unit economics is that whole stack of everything from the bucket of materials to build the product, to all the non-bill of material lines involved, warranty and so forth. I'm going to be on a quick call. I'll be right back. Keep going.
Okay. And so what is the AI advantage, Scott? I mean, you and I have been following this, and we're seeing that OpenAI's figure using OpenAI says that they're able to train autonomous end-to-end autonomous work using that. We've seen 3 grad students using the Aloha project saying that if you just teleoperate a bot 50 times, you can get it to do autonomous work with 80% accuracy rate. We're seeing just every once in a while, we're hearing people saying that, yep, our bot can do autonomous work also. And it's easier to do autonomous work than we thought is kind of some people are saying. We don't know for sure, right? Because there's so many things that can go on if they're just demoing something or it's truly effective. What do you think is happening in the AI world? And which of these bot companies, is it going to be a commodity that everybody will be able to do this? Or is it going to be true differentiators?
Oh, I mean, it's getting crazy. And today, Covariant AI also kind of released their foundation model for teaching industrial robots. And the more I see this, it seems like, man, it seems to be getting easier and easier. So if you didn't know, they're a company that has been in sort of the industrial robotic space for years. I think, doing intelligent pick and place systems for standard industrial robots. So they have, years worth of videos of industrial robots doing these different operations. And they've been using that to train a model. And now they're pretty confident that you can very easily train an industrial robot using a large language model, just telling it what to do. And that's literally the dream that I have been waiting for like 40 years, where we've been trying to do it the old fashioned way of really having to show the robot everything it's supposed to do. And if you can get it down to that, you just kind of describe what the task is that you want to have done and it does it. That's rather remarkable. And there's no reason why that couldn't be extended to humanoids. Now, they say it's like, well, this is working for industrial bots. And that kind of shocked me because I was almost expecting it to be the other way around, that you would solve the problem for the humanoids first and then eventually start deploying it in the old style, the old school industrial bots. But it looks like it may be happening almost at the same time. So, and that's very similar to what, the 3 grad students we're doing with the Aloha project, that they were able to, with some very simple demonstration data, take what are pretty much industrial arms and being able to get them to start autonomously doing different tasks. And the AI space it's heating. It's really hard to say who's ahead right now, because every day you see just phenomenal things and phenomenal developments going on in there. So it's one of those that you used to think, these guys definitely have a moat because they've got all the compute, or they have a lot of good AI researchers. But it seems that it really is close to a level playing field. Let's say it's a very competitive landscape. Okay, let's say the draft picks have been allocated in such a way that you are definitely seeing competition out there, and there may be some that have some advantage because they've got a slightly better, locker room, if you want to use that, or a training area to be able to exercise their models. But it seems to me that we don't really know who is going to be number one or who's going to be first, because they're all moving ahead so quickly and showing rather remarkable results. Things that a year ago we probably would have been skeptical that, do you really think you'd be able to do something like that? Just videotape, data and using that to start training a bot. Well, it looks like it may be possible.
Okay, so I've got a question for both of you, all of you on the panel here. So I'm dropping a video tomorrow. Interviewed AJ, ALOJOH on X, and Cern Basher and Hans Nelson, because AJ had a post and he said that he believes that just like what happened with the EV business, all of these startups in the robotic space, they will go out of business. He believes that it's like an explosion of these startups. And just like there was an explosion of EV startups, but the EVs could not create a profitable, compelling product that profitable way. And he thinks that that same thing's going to happen with the Tesla robotics business as well. There's a lot of things to consider here, but just ask that question to you guys. Do you think that that will happen? Also, clearly, there's going to be hundreds of these companies coming on board. It is definitely hype, but clearly, hundreds will die. I'm not saying that that won't be the case. But do we think that it's only going to be just a handful, like maybe 2, 5, that's going to survive and the rest will die? Or do we think that there's going to be hundreds that will survive?
Some of it has to do with the TAM. So if you look at like the TAM for smartphones, it's, around $1.5 billion a year. And you've got more players in that space. And you do have the rise of the Chinese that's happened over the last, call it decade, where there were people that were skeptical even, a decade or so, like, hey, are they going to be able to do it? And, they've been actually largely been able to do it, and they're pretty successful. It's only in certain geographies, but they are successful even on a global scale. So I think it's going to be, a number of OEMs probably higher than auto and probably below what you see in the smartphone world. If you've traveled, globally, there's a lot of OEMs in the smartphone world, but that's volume share. Then you look at profit share, and then it gets down to a very small number. You start thinking of profit share in the smartphone world. It's really, there's probably 5 or so, with, Apple and Samsung topping the profit share list. And then you probably have someone like a Xiaomi, Huawei, then an Oppo, Vivo. These are names, the last 3 I just are all out of China. So that they take the profit share, and they have a bulk of the market share too. But then there's this long tail of other smartphone manufacturers that serve just certain geographies or just names you haven't heard much of. So I think in the bot landscape is a little bit high. It's a higher barrier. It's more difficult to build a bot than a smartphone. That I can guarantee you. The mechanics involved. You have all the microelectronics involved to build a bot that are inside of a tablet or a smartphone, except you don't have the RF miniaturization concerns that you have building a smartphone. Building a smartphone in terms of getting the antenna right, all the antennas right. If you 5 or 6 antennas in your smartphone, if you think about all the different bands, modes that are in your phone, getting all that right in a very small package, there's a lot of difficulty in doing that. You won't have that difficulty, but you will have an RF component. I'm assuming these bots are going to have both Wi-Fi, Bluetooth, and probably the ability to do wide area modem, like for in case there is no Wi-Fi and so forth. So there is going to be an RF component, I believe, but it's an interesting. I don't know. Maybe it's a question back to others that have studied the space if they're going to have that or not. Yeah, it'll be more difficult. So in terms of there'll be a lot of players, Herbert. I think it'll be more than the auto world, less than the smartphone world.
Oh, you cheater! But okay, I'll take that. I like the way you think. Those are perfect analogies, actually. I think, except for the AI part. But manufacturing.
I didn't talk about AI. I didn't talk about AI.
That was my point, right? Who will survive and who won't? This adds yet another complexity to it versus just manufacturing, products, right? But okay, so more. That's good. I like the way you did that. I actually do. Scott, what's your answer?
Yeah, well, let's remember in the smartphone market, there's a lot of smartphone manufacturers, but there's basically 2 operating systems. iOS, which is proprietary to Apple, and of course Android. So you could end up seeing a similar thing with the bots, is that you may have a few that have solved it, and then with the help of NVIDIA or something like that, suddenly you have a solution for the AI, and it's just up to you to come up with a robot chassis.
Yeah. Let me quickly interrupt, Scott. Just in that point, Scott and I interviewed Sanctuary, and they said that they're bot agnostic. They're trying to build the brain's intelligence, and they're willing to partner with any bot manufacturer. we just also interviewed Fourier, Singapore-based, and they said that they are AI agnostic, where they are willing to build as many bots as possible, sell it to any company, and let them insert their skill sets, their brains, if they wish. Yeah.
Yeah, well, maybe you should invite Ben Rhodes on sometime into his spaces, and maybe he can answer that question.
Yeah, but I mean, I don't understand. Like, I don't understand that business plan. Like, how do you do that? Like, how do you say, anybody who wants to put their brains inside of it, go ahead. Well, like, what specs did I engineer this thing for? Did I over-engineer it? Did I under-engineer it? Like, I don't understand how you do that and think you've got a business plan.
That is one thing I thought was, why would you think that all these bot companies will fail except for a handful? Well, wouldn't you, like, somebody might decide to create, a superhuman bot that has the ability to carry 1,000 pounds. And then, so there's a market for that. Now, is that market big enough? I think so. That's probably a, $500 billion market, maybe even more, right? So they'll be successful just for that.
Well, yeah, I mean, it depends if they can charge enough for it, and yeah, but yeah, it all depends what they can charge for it.
Yeah,
it's called willingness to pay.
Yep, and of course, when it comes right down to, I know Jeff mentioned, the barriers to entry are a little bit higher for the bot, but it may not be as high as we thought. At first, when Tesla was starting out with, it's like, oh, they're going to have to get that bot to walk. There's not that many people that have solved.
Got muted.
Oh, sorry about that. I don't know if I muted myself or got accidentally muted there, but yeah, the whole thing with walking becomes very difficult and a challenge. And that Dennis Hong was even saying that, how difficult it was and working on it in the Romello labs in UCLA. So my feeling was like, well, that's going to be a barrier to entry for a lot of people, just figuring out how walking is going to get done. And suddenly you just see company after company after company coming up with these bipedal bots, and it seems like, oh, that's a solved problem. That doesn't seem to be, a real issue. There's clearly going to be other issues as you go up the tree. The arms are fairly straightforward because they're not that much different than the industrial arms we've been using for a long time. So the kinematics of those are pretty well understood. The hands, yeah, that's going to be something else. That's also a bit of a mechanical challenge, but there are some decent hands out there, not perfect hands, but hands that are good enough for the job. And then it just comes down to kind of solving the AI component. So I think that there'll be more than enough room for one company to do well. And I know a lot of people think it's just going to be Tesla and no one else is going to have a chance. I'm like, nah, they may be the gorilla, but there'll be plenty of chimps out there as well, and some monkeys that will be able to kind of fill in the different areas of the market. That and again, it comes down to different form factors. So if you want to talk about like vehicle manufacturers, there are a lot of vehicle manufacturers out there that you've never heard of because they make specialty stuff. School buses, for example. There's a bunch of companies that make school buses that you've never really heard of, or maybe police vehicles or ambulances or other things like that, or some cases, for the military. So there are these niche areas, even the Postal Service, the vehicles for them. What a boondoggle that was. But so there will be these others that may go after kind of the niche. And it's the same in the robotics market. I mean, the general IR industrial market, you have these big players and you would think there's no space for anyone else. After KUKA, ABB, Fanuc, Yaskawa, why are these other smaller companies? Because there are these niche products that the big boys just don't feel like they want to go after. It's too costly for them. But these other companies are able to survive there. So there will definitely be more than just a couple. I'm sure there could be dozens.
Okay. So then the next question is this. Are these companies competing with each other? Okay, so the initial reaction people have is, oh my God, they're competing. They're a competitor. We're better than they are. And then my reaction has been, well, I don't think they're going to rub shoulders against each other for 5 to 10 years. Like the market is so massive. We're talking about, the labor market is 50% of the global GDP, the world's GDP, which is $40 trillion per year. So it's not like, Tesla can create 10 factories in the next 3 years, create 50 to 100 million bots per year, and there's still room for other bot manufacturers. Or am I wrong? Some people think, no, why would anybody buy another bot if they are cost more, less capable, other issues with them, not the best. Do you guys think that these bot manufacturers are truly competing with each other than bragging rights?
No.
I mean, they may compete on performance and specs or what have you, but as long this is the fallacy with the EV world today, and there's other industries you can point to too. As long as the TAM, the total available market, is growing and can outstrip the ability for you to grow as the provider of product into that TAM, then you actually don't have you have competitive threats, but you don't have a competitive threat where it's a bottleneck to your business. Meaning you can grow and build and ship as much as to your heart's content, and the market growth itself is going to outstrip your ability to serve it. So yeah, the other people that are building and shipping robots, they are your quote unquote competitors, but they're really not. The TAM is so big that as soon as the TAM slows to the point where the providers can where supply outstrips demand, that's where the competitive dynamic comes in. And you obviously would want to plan for that years in advance and have a better product at that point in time.
Scott, did you want to answer that?
Yeah, I absolutely agree, because the market's really big, and they do rub shoulders every now and then, Herbert, at some of these different conferences, and it seems like all the leaders of these companies actually get along quite well. They know each other. They're on first name basis, and they have a high degree of respect, because they sort of realize they're more colleagues at this point than they are really competitors, and that's really kind of nice to see that they kind of have that sort of feeling about what's going on, is that they're kind of in this whole thing together as opposed to against each other.
Okay, so let's talk Tesla stock, Tesla bot. People still say, oh, you're throwing out yet another hopium, right? This is something that a breakthrough needs to happen for this to succeed. It's we don't know if it'll still succeed. Are we still at that point? Do you guys still believe that this is a startup that is not proven? Obviously, they haven't sold it. Obviously, this is they've only done demos, and you don't know what it truly can do or not. So there is certainly a lot of hopium still. But when you're looking at a massive market like this is, I don't know how much bigger. What the way he said it was 10 times at least, maybe 100 times bigger than the auto market, right? This is so big, the opportunity here that. And they don't even have to sell it, right? It's just the use of the bots within their own factories. We have to figure that out. I think I asked this question. I don't remember if I asked it to you, Scott. How many employees within a factory can be replaced by a humanoid? And somebody told me 50%. That was their estimate. But so how big of a deal is it to Tesla? What do we have to wait for before we believe this is a real successful business that will be very successful, right? It's all probabilities, right? So I'm not saying it's 100% ready now, but there's a higher probability than not. And tell me what you guys are thinking.
Yeah, my overall feeling is that the Tesla bot will affect the bottom line of Tesla before Robotaxi does. It doesn't mean they'll be selling the Tesla bot, but that the Tesla bot will actually impact the margins of the production of the vehicles that they have. So there's less pressure on Tesla to actually have to get this out of the market and start making a profit that way than the others. So in that sense, they will be earning money earlier before everyone else because of that. It does not have to be a polished product. It can definitely be doing a lot of things, because they're able to control the narrative of how it's being deployed, where it's being deployed, what kind of operations it's doing. And they already have a pretty good idea of I'm sure they've already gone on the list of, like, we know this is the low-hanging fruit that we can start to go after. And when that starts to happen, that's when it probably starts to dawn on a lot of the investors that, wow, this might be a real thing. When you see the margins go up and everyone's scratching their head, but wait a minute, how did they do that? Were they reducing COGS? What was it that did it? And they suddenly realized, oh, that couple % change was because of labor costs suddenly changed. Then everyone begins to realize that, and then you can start to extrapolate from there. It's like, oh, what does it mean when it starts to go outside of Tesla? And again, don't get ahead of your skis and thinking that, it's going to be in homes tomorrow. It doesn't have to be. once it starts getting into the tier 1 and tier 2 suppliers of Tesla, so they'll be sort of be able to make money there, and at least whether they're leasing it to their own suppliers, in other words, making money off their own suppliers, or if it's just the fact that they're able to drive down then the cost of the things that they're getting from the suppliers, to the point that maybe the suppliers are not just using it for the production of Tesla parts, but also for their competitors or other products, in which case Tesla is also, let's say, getting a little bit of the benefit of the other production that's coming out of those companies. And then eventually it'll be something that goes outside of any of the tier suppliers that affects Tesla into other manufacturing for a long time. And again, I think CERN did some pretty interesting calculations showing that it doesn't really take a whole lot of robots, just Tesla branded robots, go out there to have a huge impact on the profit of Tesla. And we're just talking about the order of like a million to 1.5 million bots. Adds a lot. So it's not like it has to be tens or hundreds of millions of bots, but just actually a small number that's able to definitely go after that low-hanging fruit and save significant cost in production and labor will definitely affect the bottom line to a substantial amount.
Okay, so Jeff, how are you thinking of this as a bet on Tesla stock?
It would have to be at a point where analysts could model future earnings, and you could be a year out from those future earnings. But if there's some confidence that it can be put into a model, and there's some confidence, let's say you think 10,000 of these bots are going to be sold at some price. They'll probably load that into a model and maybe multiply it by 50%. Maybe there's 50% probability of that happening. But when it's in the point where you're within a year of being able to model that, when you're in a year of where that you could have it in a model where it would be in production a year from now, from that point, that's when it'll start impacting the PE of the stock. And for it to get there, I think there's going to have to be a lot of confidence that, like you see the bots and they're working in the warehouse. They're working, I've always said they're going to start in the perimeter of the factory and work their way in towards the middle. Just in my experience in factories, that's where you would start something like a humanoid, but that's obviously it's debatable. But yeah, I think you're going to have to, there has to be confidence that they work. There has to be confidence that they replace labor. There's have to be confidence that they replace labor at a better efficiency level too. That's the other thing. It's not like you can just, put these things on the line. They're slower and they make more mistakes. They've got to be able to be, at human speed and at or better than human level quality levels. And then, when that confidence is there, and Tesla says, "I can build this thing." That's the other thing. You need to hear out of Tesla's mouth that they've gone to production. Sorry, they've gone to design lock on the bot. Like they sprung this Gen 3 on us. Nobody expected, we get surprised when we see these new generations come out. But at some point, Tesla's got to say, we're design locked. They did that on the Cybertruck in May of 2022, and they were in production about 15 months later. I would say there would be a similar, maybe 12 months or so, 12 to 15 months of, hey, we're design locked on this thing, and then they'll be in production 12 to 15 months later. So I think that whole progression has to play out.
Yeah, you actually are answering the question I was going to ask, right? So we had Elon. So first of all, we're seeing these demos, which is great, right? It's like exciting, but you have to take that with a grain of salt. Then you have Elon saying, which surprised me a lot when he said that the earnings call, we might have some number of Optimus being shipped next year, right? That's great, but it's Elon, right? So you got to take that with a grain of salt. But then when you look at all the hiring that they have, Jeff, can you speak to that? I mean, like you and I have been following this, Alexandra as well. There is a lot more people that are hiring, 24 hours a clock, even mid graveyard shifts for these folks. And you were saying that the difference between the hiring that Tesla's doing versus all the other bots that we've seen so far, Tesla's doing manufacturing roles. They're already creating a production line for the bot. So that's the one thing I think we can look at and say, okay, that sounds like they are a little bit more confident than just words or just, demos. You know what I mean? Like, so yeah, how do you evaluate? Is there anything else that we can be looking at to give us a little bit more confidence on the progress?
No, I mean, yeah, look at their, first off, I mean, it's a tricky game. I mean, Tesla is hiring for those roles. It takes, 4 to 6 months probably to hire for those roles. So you have to put that time span on it. And then, so they maybe just be ramping up that industrialization bot team now. And then, and then that team has to work, that industrialization team. I've had those teams work for me. I came up as an industrialization engineer. You start that work in the early kind of like prototyping and concept phase of a product, so you actually influence and steer, the DFX side of it, the design for manufacturability side of it, and then at that and in parallel, you're actually designing the actual manufacturing line and process and tools to build it. So what that all means is, they could, if he says that they're going to be producing, we don't know what they're going to be producing. Tesla can call it whatever they want to call it, especially if they're going into their own factories. But we need to hear him say that he's design locked the bot for at least for the initial generation of product. And then you can probably put a clock on it of around 12 to 15 months for it to be, entering mass production. Yeah, those are the clues. I think, yeah.
Are you using the same time frame as you would for the car, though? Should be quicker than a car.
No, I'm using the same. Well, I'm using the same. I wouldn't be quicker than the car because I think you're going to have a lot of unknowns. Tesla knows more about industrialization of cars than they know about bots. Even though eventually, at some point, when they're 5 years into making bots and 15 years into making cars, it'll be clear to them that bots are simpler to do. It's gonna be the things you don't know that are going to trip you up. So
yeah,
I wouldn't be. And by the way, on the phone side, it's if you're a Chinese player, it's 6 to 9 months to industrialization. They're much faster. The U.S. teams are closer to 12 to 18 months, depending on the product, for industrialization from design lock. So, but everybody has slightly different definitions. But to answer your question, Herbert, I don't know. I know that Tesla knows here's what I know. I know that Tesla knows what they're doing. Like, I know Tesla knew that, like, hey, we're going to put this thing into production in 2025. We better hire this industrialization team in Sparks and get it ramped up right away, get the MPI line built. I don't know if these other teams, if the fact that they haven't hired these roles, I don't know if, what they're, I don't know. It could be as simple as they're way behind Tesla, or they don't know what they're doing. And they should have put these recs out for these people, and they haven't. So we don't know. We don't know the answer. We shouldn't assume that they all know what they're doing.
Yeah, I think that most are still saying that the form factor of the humanoid, the hardware itself is not quite yet there. Shockingly, though, Figure says that it should be design lock within 6 months. He feels that that's where they're at, the hardware part. But yes,
right.
I think that people are going to say, I'm not going to build the, other companies we talked to, they said something like, we are obviously thinking about supply chain and manufacturing, but right now it's still hardware and autonomous work, right? And so until you got that nailed down, you're not going to think about scaling. But maybe your time frame is, you're basically saying somebody with experience, you should really be doing it at the same time as you are prototyping. That's what you're saying, right?
Yeah, the industrialization team should be in place as you start building. My recommendation to companies is that they're in place before the first prototype. You don't need the whole team, but you need the core of the team of, like, how is this thing going to be mechanically assembled, and how is this thing going to be electrically tested? And then you need to have those, and then any major supplier partnership person, like, you would need like those 3 people hired right away. So maybe they have them and they're just not posted. And that's certainly possible, but you need that small core of people before the first prototype is made. And then once you're making the first prototype, I would have the full team, quite frankly.
Scott, I'm going to force you to rank the bot manufacturers, and I know that they change every week. The rank will change, and I know that we shouldn't be ranking them, but just want to know your opinion. So who do you think is in the lead?
Well,
Who's next?
what I would do is right now is there's a perception issue out there right now. Those of us who believe the bots are coming and those who are extremely skeptical. So everyone's seeing these demos and go, oh yeah, the demos are very good, but they don't show us very much. So we may look at it and say, yeah, there's some impressive aspects of it, but the general public and certainly the analysts are going to say, no, there's really nothing there that we can see. We need to see a better public display. Well, there's a trade fair going on in Atlanta right now called Modex, and Agility Robotics is there, and they have their digit bots performing during the entire show. And as a matter of fact, they have a webcam that's just sitting there and you can watch it all day, which is what I've been doing this whole space right now.
And they're moving fast, Scott. They're moving pretty fast. I'm watching the humans behind them.
Yes.
And it's real-time live stream, and they're moving faster than I expected.
Yeah, they're going along. So what it means is that like anyone who's kind of skeptical might look at that and say, oh, maybe they are coming. And if Agility can do it, maybe these other guys are really doing it too. So I'd say from the standpoint of public perception, I'll say Agility is number one right now, because this is the second year in a row that they've done it. And again, it was pointed out in an article that they're here alone. They're the only one doing it. Where's everyone else? You know, if they're supposed to be up there, why do they have the courage to do that? So they're running nonstop. Now, because I'm being a nerd watching this, I'm able to see that they run for about an hour, they go in and charge, and another one comes out and replaces them. But still, it shows that it can be done. You could have bots doing this operation nonstop.
But Scott, yeah, I just want to clarify. Digit has pinchers, and they don't have feet. They can walk, but they have different legs. They're humanoid-like, and they were designed for a very specific job, very specifically pick and place only. The others are trying to create a general purpose humanoid bot that once complete will be able to do almost any task. And that's why they're ahead, but they're very specific.
They're ahead because they're in a niche, but the thing is, they're in one of those niches which has a pretty big total addressable market in the logistics, and it's definitely low hanging fruit. And it's like, man, you almost don't need hands, even though for one of these applications, they came up with a type of pinchers to be able to do it. So they demonstrated they could do it. The main thing is like, you know, whether it's technically a humanoid bot just because the legs aren't quite the same and this and that, doesn't matter. It's the perception that when people start seeing this and begin to realize that, they're coming, I'm wondering if that starts changing the overall viewpoint of analysts and everyone else when they start thinking of either Tesla stock or anything else, and that, oh, maybe this Optimus project isn't a waste of money. Maybe it is really something that will add value, as well as these other bot companies that are out there. You know, maybe it isn't just money that's being thrown away, but something real is going to happen.
Keep going. So you got Digit. You think because they're already physically out there and they can show.
Yeah, they're physically out there. So what I'll do is I'll give. Let's say from the standpoint of public relations and out there, they win the week. Okay. I think they've kind of got themselves in the news a bit better than everyone else. You know, obviously the week before, it was certainly, you know, Figure with their announcement, and then Tesla right after that showing the Tesla bot again. But they've both been kind of silent. And, you know, Agility has kind of come out swinging and said, hey, you know, here we are. Look at what we're doing. We're the only ones showing up, willing to demonstrate publicly. I mean, full public demonstrations. You can fly into Atlanta, you know, go to Modex tomorrow. Walk right in there and see it and observe it doing this thing for, you know, the entire length of the show. Now, again, one thing I wanted to know was like, wow, what's the charge time on these bots and how long can they last? It seems like they're doing hour shifts. So they're using the bot as the swappable battery pack. I suspect they could go a little bit longer than an hour, but, you know, they brought four bots here, and, you know, just two of them are operating at one at a time, and then they go in the back area and then have their coffee break and charge break and then come back on out. So it's showing the feasibility of these solutions, that we're getting closer and closer to that day where people are going to realize, yeah, this is really working. So yeah, I'll just leave it there. There's obviously were a bunch of other Chinese robot startups that came up, and even another announcement out of Alberta, of all places. So there's a lot of interest and a lot of people that think they can crack this nut.
And then probably guaranteed, there's projects and companies that have not revealed anything, and they may be further ahead than the ones who did do demos, right? They're just trying to get out there marketing wise. Yeah.
It's possible. I mean, the whole question is the stigma associated with it. So if you announce you have a bot product, does that make your stock go up or does it make it go down? You know,
well, many of these are startups, though. Just to be clear, the only company that you can, if you're into humanoid bot, that you can invest in is Tesla, because they're public. The rest are startups that have, either Series A, B, or C, right?
Correct. There might be one or two Chinese bot companies that I think are on the Hong Kong exchange, but yeah, from the standpoint of North America, there's only one that I'm aware of, and that's indirect through Tesla.
Okay, and you're not going to say anything else about the next one, or?
Oh no, I say I don't like playing these ranking games, but they're all doing quite, because if you pick a certain niche, you can say, yeah, they're leading. So from the standpoint of logistics, you've got agility is clearly leading because they're demonstrating it, and they could probably go in there and do it. If you want to start looking at things that are going to require more dexterity, it's hard to tell because they're not showing us what they're doing. We don't know what they're doing in those back rooms. We know that Optimus could be doing quite a bit, but all we're seeing is it's walking figure eights. Certainly Figure has maybe shown us a little bit more as far as what it's able to do. It's doing a similar kind of task that agility is right now, but using the full hand for it. But again, a similar kind of thing of picking up a tote and moving it over to conveyor back and forth. Agility is definitely doing a little bit faster. You have, of course, Unitree going 7 miles per hour with their bot, and able to jump and everything else. Able to do a simple pick and place because it doesn't have fully formed hands again. And we don't know how good the AI is in it and whether it's all heuristically programmed. But again, if we're going to be ranking these in the decathlon categories, the 100-meter was won by Unitree.
Because they demoed their bot to be able to run.
Yes, they ran faster than they also and it looks like they also won the high jump. Okay, so the only one that's demonstrated running and jumping. Okay. and then you go to the next event, and the event is like the tote pudding, okay, the put wall, right? So you give that to agility because they're a little bit, and the silver goes to Figure because they could show it, but they're not quite as speedy. So we can kind of go on down the decathlon, and all I could do for Tesla bot at this point is that, well, I think they win the walk. The walking event because the walking event you're not allowed to run, right? And so it's like the most graceful walk, and they get style points for that. So the elegance that you see with the Tesla bot going around. So right now I think you have to kind of almost look at it as like these different events in the decathlete and the decathlon. And then of course you get Sanctuary, which is really, really fast with the pick and placing of being able to pick up blocks and move that really. And I think there's two things we have to look at there. One is at first, mechanically they have something that's quick enough to be able to do it. You would think these other bots mechanically should also be able to do it, but why are they kind of a little bit hesitant? And it might mean that the overall control system or the the brains of the operation just can't keep up quick enough. They're hesitating because they're thinking about the problem. So the fact that you're seeing that kind of speed coming out from Sanctuary is like, wow, okay, they've got an AI that is like calculating really quickly, and then you can tie it with the good mechanics, and we know it can be done. And each one of these, as far as I'm concerned, they're showing us the first principles. Now that we know Unitree has been able to come up with a bot that can go 7 miles per hour, there is no reason why the others could not. There is no physical limitation why they could not. They might have to do some major changes or some compromises here and there, but we know it's possible to make a human bot go that fast. What we don't know is how long it can go that fast. It may be that, the batteries run out of charge in 20 minutes, in which case it's like, okay, it's nice that it's fast, but that's not useful. We got to make sure it can do it for a sustained period of time.
Yeah, you and I interviewed another bot manufacturer. I'll leave them out for now, and they were saying that the actuators are a lot harder than you think. Like you can create an actuator, but if it doesn't do much, then it can last for like 4 hours. But if you're keep moving, it will only last for 30 minutes, and then
right. And of course, from the design, I didn't see that they left a whole lot of room for the batteries. So there was a lot of degrees of freedom. And see, these are the compromises that you're making when you decide that, oh, we want to have a lot of movement in the torso. So, down basically in the area of where your belly button is and around there, you could decide that I want to have 3 degrees of freedom there because I need to have all that movement. Now, if most people, I mean, unless your young child is really flexible, we don't have that much flexibility in our bellies left. There's a little bit down there, but most of that kind of movement we take care with our hips in other places. So if you decide to put that into your bot because you think that's what you need, you're taking up a lot of room down there, and you're adding some additional mass. So by doing that, suddenly your chest cavity is not as big as you want it to be. You can't put as many batteries in there, and you're not having to carry one extra actuator. So in the Tesla design, they decided to drop one of those actuators there and then actually get that kind of bending or sitting motion through the movement of the legs, which is how most of us typically do it. Yeah, we can do a little bit on the sit-ups, but for the most part, we can keep our whole back completely straight and be able to do that. And these are the design compromises that you constantly have to make to decide between, okay, longevity, how much power consumption. And remember, when those batteries are sitting there, they're not just extra mass you're toting around. They may also be consuming energy just to be able to lock themselves into place. So even if it's not moving or doing anything, it's draining the battery a little bit. And the same decisions that you're going to have in the head. How much movement do you need to have in the head? Do you want to have full degrees of freedom? Well, again, you might be taking up a lot of room that you might normally then have for being able to stick your batteries and other vital components in. And again, it comes down to like the swappable. Yeah. Mm-hmm. Yeah. What was that,
Sorry,
Jeff?
Scott.
Go ahead.
I don't want to interrupt you. I apologize. I was just going to say, we have to ask ourselves when we see these demos, why are they giving us these demos? And they're giving us these demos because they want to raise money
or hire.
I've often said that, Tesla, I mean, quite frankly, they should stop. They should stop doing demos that reveal, critical functionality, unless they don't care. It could be a thing like they just don't care. But if Elon's made this comment of like, I do these demos on AI Day, and then I find out that they're less for recruiting and more for my competition to just copy me and go forth and do. I mean, it's not I don't think it's a coincidence that this bot craze kicked off. I think Tesla honestly kicked off a lot of this effort. There's been talk of humanoid bots in manufacturing for decades. I had a conversation with Terry Gao from Foxconn about this a couple decades. I mean, that was his vision of like, I'm not going to have this labor constraint anymore in China. We're going to design bots to do all this. There's been talk about this for years, but as soon as Tesla said like, hey, I'm making this a priority, I'm putting capital behind it, it's the next big thing, and this is why, I think a lot of people just jumped on board. So I think Tesla should be, honestly, if they're not in a mode of raising capital, which that's a debatable thing, we could talk about that on another show, but if they're not in a position where they need to raise the capital to do the bot program, I don't know how much they need to really be exposing to everyone. And again, unless they don't care, like we're just going to out innovate everyone and it's not going to be close.
It's hiring, right? They want the best AI minds in the world.
Yeah, that's part of it. Figure and the others have also at the bottom of there is just say, hey, we're recruiting. If you want to work for the best AI team, come join us. So they're using it for that. And certainly after the capital raise, there's no need for them to drop videos anymore. They've done that. But Jeff, I do remember you posting those sentiments, I think a couple of months back, that you felt going forward, Tesla should not post any more videos for that reason. And right after I read that post, I was seriously considering blocking you.
Yeah. Well, yeah. Sorry, I know.
Jeff, don't do that to me, man. That's my living.
That's our living. It's all my breaking news, Jeff.
Don't worry. Yeah.
There's other reasons to block me besides that.
Yeah. Oh, but that was like number one for me right there. It's like, what? Jeff, I can say no more Tesla bot videos. No, how could you?
Okay, so let's go back to the benefits of Tesla, right? So it's one thing Tesla is able to create an electric vehicle, a profitable, really an amazing, compelling product that people love, right? Then they're going to have autonomous, the ability to actually improve the ADAS, the safety of the vehicle, and eventually even robotaxi. So what are the other car companies going to do to compete with that? And then when they have the bot at scale to help them even further reduce increase their margins and reduce their costs, I don't know if a bot in this factory can actually make more cars faster, maybe more cars. I don't know, but certainly costs would be reduced, right? You know what I mean? Like at that point, how can anybody compete? Could you know what I mean? Like I know BMW's partner with Figure, but how many can they buy? And what about the other all the car manufacturers are going to be sitting there waiting for orders to be filled.
Yeah, I mean the economics would be invariably worse unless Figure figures out something that Tesla just completely missed, where they can supersede the economics from Tesla, basically selling to themselves, just like Samsung today sells displays from their display division to their to their mobile phone division. They sell memory from their memory division to their phone division. So Samsung has this discrete edge on really a lot of the unit economics that go in a mobile phone. They've got the edge of not having to pay that margin. I'm sure they're paying their division some margin, but in general, they don't have to pay themselves anywhere near it. So anyway, the point is like Figure would have to figure out something that could supersede Tesla and the ability for them to build and sell to themselves. So I mean, yeah, I don't know.
BYD is so successful because they make their own batteries, but Tesla buys BYD batteries too. So it's okay. Like
well, BYD does more. Just BYD, BYD has all the component capability. I mean, they do. I mean, for mobile phone, they do all kinds of forging, metal stamping, everything. And for cars, I'm assuming they're doing most of the supply chain. They're doing themselves. So they actually have pretty expansive of capability with vertical integration. So anyway, I mean, back to your original question. I think your original question, Herbert, was around path of success or who would get there faster?
Tesla, specifically Tesla, right? They have their EV costs and margins already so good, and then they're gonna have autonomous, and then they're gonna have bots.
Oh yeah. Well, the bot is going to have to move faster or move at equivalent human speed or faster, and have equivalent or better capability in terms of defect level and number of actions they can do in the factory. Then it will become accretive pretty quickly. But there's two barriers, to labor. The labor, there's two things going on with labor. One is the cost once you have the labor. The other piece of it is just acquiring labor. And what's the time? This is something that companies measure, is the time from T equals 0 to your line being at peak run rate. And could you get there faster with humanoids than you can get there with humans? That would be another major factor in improving the lifetime economics of a product line. So I think there's three things. One is the actual rate, and I should probably discuss this with CERN more, but one is the actual, hourly rate piece of it. Got it. There's no dispute there. The other piece of it is just acquiring labor that you can't acquire in certain places. That takes a period of time to do. If not, sometimes you can't do it. And then the third piece of it is kind of that lifetime efficiency. And can the bot actually be, faster and perform at a higher level? And can that bot get you to peak run rate faster than a human would get the peak run rate?
Yeah, CERN and Scott have actually modeled it out already, that even if a bot is working at 50% the speed of a human, it's still economically better. And then, of course, if it can do the same job at the same speed, but what happens when it can do it twice as fast?
No, but I understand that. But if it's working at half the speed, that may be good enough for the labor component of the unit economics of making that vehicle. But the labor component of the unit economics of making a vehicle are very small, actually, relative to the rest of the unit economics of the vehicle.
Sorry, explain that.
The labor component of making a vehicle is if you stack the total unit economics of, let's say you're building a $35,000 Tesla Model Y or Model 3. The labor piece of that, I would imagine, is somewhere on the order of between $5,000 and 11% or 12% of that total cost would be the labor component of the product. So if you have the labor, if you could run the labor at human speed but be at half the cost of labor, you're going to gain ground on that 5 to 11% cost structure. So you're going to gain 2.5 to 5%, which is a big number. But there's a lot more going on in the total unit economics of the vehicle than the labor component is my point.
Okay, understood. All right. Thank you guys very much. I appreciate your time. We explored not only TeslaBot, but all the other humanoid startups and a variety of questions that people have been asking. So thank you, everybody. Join us for this weekly Cyber Bulls podcast that we do. Thanks, everybody. Bye-bye.
Thank you.
Yep. Thank you, Herbert.
See you, Scott.
Yep. Bye, Jeff. Bye, Xander.
Don't block me.
Yeah, don't worry. I won't.
Bye, guys. Great job.
See you, Xander.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.